Derivative and antiderivative. Let's start from some examples. The first derivative of x squared minus 2 equals 2x. The first derivative of x squared equals 2x. The first derivative of x squared plus 1 is also 2x. If we generalize this to be the first derivative of capital F, let's say the result is small f. So there is a question, how to find the original function capital F from the first derivative small f? The answer is to reverse the process. So the process of finding capital F such that the first derivative of capital F equals small f is the reverse of differentiation. The capital F is called antiderivative of small f. Once again, look at the examples. X squared minus 2 is antiderivative of 2x, x squared is antiderivative of 2x, and x squared plus 1 is antiderivative of 2x. For generalization, capital F plus c is antiderivative of small f. C is an arbitrary real number. Since capital Fx plus c is antiderivative of small f, mathematically is written like this. The symbol like letter S is a symbol for integral. And because we involve c, which is arbitrary or indefinite real number, so we can say this integral is indefinite integral. So the definition of indefinite integral is as follows. If the first derivative of capital F equals small f, then the indefinite integral of small f is integral small f dx equals capital F plus c, where c is an arbitrary constant. Let's see some examples. Example. Rewrite the first derivative of 3x to the power of 7 minus 5 equals 21 x to the power of 6 as an indefinite integral. Based on the definition, we have the integral of small f equals capital F plus c. Now, from the question we have 3x to the power of 7 minus 5 as capital F and 21x to the power of 6 as small f. Substitute this to the definition, we have the integral of 21x to the power of 6 dx equals 3x to the power of 7 minus 5 plus c. Since minus 5 plus c is an arbitrary constant, so leave it as constant or c. So we will simplify the definition to be 3x to the power of 7 plus c. This is the other example. It is given that y equals 2x plus 5 to the power of 4, find dy dx. Hence, find the integral of 2x plus 5 cubed dx. Part A, y equals 2x plus 5 to the power of 4. So using the chain rule, dy dx equals 4 times 2x plus 5 cubed times 2. And simplifying this will give dy dx equals 8 times 2x plus 5 cubed. From the previous work, we have dy dx equals 8 times 2x plus 5 cubed. Or, the first derivative of 2x plus 5 to the power of 4 equals 8 times 2x plus 5 cubed. Dividing both sides by 8 and by constant multiple rule, we have the first derivative of 1 over 8 times 2x plus 5 to the power of 4 equals 2x plus 5 cubed. So now this is the capital F and this is the small f. Now by the definition, we have the integral of small f dx equals capital F plus c. Substitute the value of capital F and small f, we have integral of 2x plus 5 cubed dx equals 1 over 8 times 2x plus 5 to the power of 4 plus c. It's probably difficult using the definition. Now let's use some formula for integrals. Here are some integral formula. The first one, the integral of a dx equals ax plus c. Second, the integral of x to the power of n dx equals 1 over n plus 1 x to the power of n plus 1 plus c. N is not minus 1. The third, the integral of ax to the power of n dx equals a over n plus 1 x to the power of n plus 1 plus c. N is not minus 1. The last one, the integral of ax plus b to the power of n dx equals 1 over a to the power of n plus 1 times ax plus b to the power of n plus 1 plus c. N is not minus 1 and a is not 0. Alongside the integral formula, we have integral rules. Constant multiple rule. Integral k fx dx equals k times integral fx dx, where k is a constant. Sum rule. Integral of fx plus gx dx equals the integral fx dx plus integral gx dx. The difference rule. Integral of fx minus gx dx equals integral fx dx minus integral gx dx. Example, find the integral 1 dx. Here is the solution. Based on the formula, integral a dx equals ax plus c. So from the question we have integral 1 dx. It means that a equals 1. So substitute back to the formula, so we have 1x plus c. So the integral of 1 dx equals 1x plus c. This is the other example. Find the following integrals. Part A, integral x to the power of 6 dx. Part B, the integral 1 over x to the power of 4 dx. So here is the solution for part A. The most suitable formula for part A is using the integral of x to the power of n dx. So we will use this formula. The integral of x to the power of 6 dx, it means that n equals 6. Substitute the value of n equals 6 into the formula, so we'll obtain 1 over 6 plus 1 times x to the power of 6 plus 1 plus c equals 1 over 7 x to the power of 7 plus c. Part B. The integral of 1 over x to the power of 4 dx equals integral of x to the power of minus 4 dx. So here we have the value of n equals minus 4. Substitute the n equals minus 4 to the formula, we will obtain 1 over minus 4 plus 1 x to the power of minus 4 plus 1 plus c. Simplifying this will give 1 over minus 3 times x to the power of minus 3 plus c, or minus 1 over 3 x to the power of minus 3 plus c.
Example, find the integral of x squared minus 1 times 3x plus 5 dx. Here is the solution. So expand the function inside the integral, so it will be the integral of 3x cubed plus 5x squared minus 3x minus 5 dx. By the sum and difference rule, we will have this, and using the constant multiple rule, we have 3 times integral of x cubed dx plus 5 integral x squared dx minus 3 times integral x dx minus 5 times integral 1 dx. So the result will be like this. The integral of x cubed dx is x to the power of 4 over 4. The integral of x squared dx is x cubed over 3. The integral of x dx is x squared over 2. The integral of 1 dx is x. The final result is 3 over 4 x to the power of 4 plus 5 over 3 x to the power of 3 minus 3 over 2 x squared minus 5x plus c. Here is the other example. Find the following integral 7x plus 5 to the power of 6 dx. So the solution is using the formula of integral of ax plus b to the power of n dx. Now, based on the question, we have a equals 7, b equals 5, and n equals 6. So we will substitute all these values to this formula. So we will obtain 1 over 7 times 6 plus 1 times 7x plus 5 to the power of 6 plus 1 plus c. So simplifying this will give 1 over 49 times 7x plus 5 to the power of 7 plus c. So here is the example involving the curve. The gradient of the curve at any point x, y on it is given by dy dx equals 2x minus 3. Find the equation of the curve if it passes through the point a, 2, 3. So based on the question, we have dy dx equals 2x minus 3. And using the integral, we have y equals integral 2x minus 3 dx. Solving this will give integral 2x dx minus integral 3 dx equals 2 times integral x dx minus integral 3 dx, and it will be like this. The integral of x dx is 1 over 1 plus 1 x to the power of 1 plus 1 minus integral of 3 dx is 3x plus c, and simplifying this will give 2 times 1 over 2x squared minus 3x plus c equals x squared minus 3x plus c. So y equals x squared minus 3x plus c. Based on the question, the point a, 2, 3 is on the curve. So we can substitute the value of x and y to the curve. So based on the question, we have 3 equals 2 squared minus 3 times 2 plus c. 3 equals 4 minus 6 plus c. So 3 equals minus 2 plus c, or c equals 5. So we have c equals 5. And then the equation of the curve is y equals x squared minus 3x plus 5 by substituting it back to the curve.
Stay at home, tetap semangat!